Hello class. So the purpose of this video is to be able to go over the concepts of 3.1, 3.3, and 3.4. So it's broken down by learning goals and we'll do the problems for each goal. So learning goal number 1, classify the polynomials by identifying the standard form, leading coefficient, degree, and the number of terms. So for this one, using the highest power here, the highest power is 20, so my degree is equal to 20. My leading coefficient is the number that is multiplying the highest power. So in that case, there's an invisible 1 here. So my leading coefficient is equal to -1. Now we got to put it in standard form and find the number of terms. So let me do the number of terms first. So for the number of terms, we have 1, 2, 3, 4. So 4 terms. All right, now we're going to go ahead and put it in standard form. So we have -x to the, so we have, let me write f of x equals -x to the 20th, the highest power first. Then so that's that guy taken care of. Now the next one is the next highest, so positive 100x to the 8th. The next highest is positive x to the 5th, and then positive x squared. That's our standard form, and those are our three characteristics here. So now let's do it for number 2. So for number 2, you're going to add up the powers here. So that's going to be 9. You're going to add up the powers just to determine the degree, nothing else. That's the only reason why we add the powers here. So this will be 16. This is a 1 here, so this will be 4. And then this will be 6. So the degree is going to be 16 here. All right. So now that we got that, we need our leading coefficient. So leading coefficient here is positive 9. Now we need the number of terms. So we have 1 term, 2, 3, 4. Now we put it in standard form. So like we said, the highest power is this guy, the 9x to the 6y to the 10th. So we got f of x equals 9x to the 6, y to the 10th. Next we have, the next highest power is 9, 5 plus 4, so we have 8x to the 5th, y to the 4th. Then we have 6 for the highest power, next highest. And then lastly, minus 5x cubed, y. So that's our standard form. All right, pretty straightforward. Next learning goal, we're going to determine the end behavior of polynomials. So this is the snowman activity that we did in class. So for the end behavior of polynomials, remember that there are 4 cases that we have here. So let's look at the cases by looking at each snowman problem. So we have here -x to the 7th. I'll write it down. You know, that's this guy. So we have -x to the 7th plus x. So notice that the degree here is 7. That's the highest power, and that's odd. And the leading coefficient is an invisible -1. So that's going to be negative leading coefficient. So if you got a negative leading coefficient, then your end behavior is going to behave in a certain way. So for negative odd, the end behavior is up, then down. Now if you have trouble figuring this out, what you could do is plug in a number on the left side here. So plug in like a negative number. So remember, these are negative numbers for x. So if I were to draw like a number line, here I'll do it on the number line here. So we got up, down. So here, these are negative numbers for x, right? And these are positive numbers for x. These are negative numbers for y. These are positive numbers for y. So when x is negative, let's plug in a number like a negative number. So we got negative, let's plug in -1 for x. That way we can test this left side. So -1 to the 7th is -1, and then we got another negative on the outside. And then this is obviously negative. And then a double negative here. When you do this, yeah, I forgot. So when you plug this in, you're only concerned with doing the highest power. So we're only going to plug it into the highest power. I apologize for that. So you don't have to include anything else, just the highest power. So -1 to the 7th is -1, and then we had a negative there, so that makes it into a +1. Okay, so when you're doing end behavior, remember that you're only looking at the highest power. So I almost made that mistake there. So that means that it's going positive, so that means it's going up, right? So which is why we drew the arrow up. Okay, I'm going to erase that arrow because we're going to figure that one out. Now let's plug in a positive number for x. So if I plug in +1 into -x to the 7th, this is what I'm going to plug it into. So I got +1 to the 7th. So we got 1 to the 7th is 1, and then we got a negative on the outside, so this is going to be -1. So that means this goes down, and then this one went up. So that means that when I plug in a positive number for x, the graph goes down. So the arms for the snowman go like this. So like we said, if we plug in a negative number for x, then we get a positive for y. So when x is -infinity, y is +infinity. So as x approaches -infinity, y approaches +infinity. All right, now as x approaches +infinity, y goes down to -infinity. So as x approaches +infinity, y approaches -infinity. All right, so that's the case for odd negative. So odd negative has up down. Now we're going to look at odd. We're going to look at another case here. So this problem right here, I'll just rewrite it. -x² plus 1/2 x to the 5th. So this problem, if you look at the degree, which is the 5, that's going to be odd. So we're going to circle odd. And if you look at the leading coefficient, that's +1/2, so it's positive. So now we're going to focus on this part only, and we're gonna plug in a number to the left and to the right, a number that is negative and a number that is positive. So let's plug in a negative number for x, like -1, focusing only on the box part, the highest power. So -1 to the 5th is -1. -1 times 1/2 is -1/2. So it's going to be a negative number. So that means it goes down. So when x is negative, the y goes down to negative. So when x is -infinity, y is -infinity. All right, now let's plug in a positive number into, again, this box part. So 1/2 times +1 to the 5th power. Well, 1 to the 5th power is 1. 1 times 1/2 is 1/2. So this is positive, so it goes up. So when x is positive, y goes up to positive. So it goes up. So when x is +infinity, y is +infinity. All right, so that means our snowman arms go down on the left and go up on the right. All right, so now we got those two cases. We got two more cases to look at. So if you look at here, we have 1 plus x² minus x to the 4th. and that is even for the highest power, and there's an invisible -1 there, so the leading coefficient is negative. So now let's focus on just the highest power term, which is that. So let's plug in a number. Let's plug in a negative number first. So like -1. So -1 to the 4th power is +1, but we got the negative over here. And then a negative and a positive is a negative, so we got -1. So that means it goes down. So when x is negative, y is negative. So when x is negative infinity, y is negative infinity, as x approaches negative infinity. Now let's look at when we plug in a positive number for x. So let's plug in +1 to the 4th. Well, we don't have to write the positive there. 1 to the 4th is 1, and then we got a negative on the outside, so it's -1. So that means it goes down. So then in that case, when x is positive, y goes down. So we got negative infinity. Now let's look at the last one. Oh, let's do the arrow arms for the snowman. So down, down. All right, last one. So we have 2/3 x to the 3rd plus x to the 6th. So it's even for the highest power, and +1. So it's positive for the leading coefficient. So now let's focus on just the highest power term. So let's plug in, let's do a negative number first for x. So if I plug in -1 to the 6th, well, -1 to the 6th is +1. So it's going up. So when x is negative, y goes to positive infinity, which means that the snowman arm goes up. And now let's plug in a positive number. So if I plug in like +1 to the 6th, I also get +1. So if I plug in positive for x, y goes up. So the snowman arm goes up, and we have positive infinity. So those are my 4 cases for end behavior. All right, so now we're going to be looking at learning goal number 3. So use polynomial identities to multiply expressions. So I went ahead and listed out the polynomial identities on the right-hand side. Those are the ones that we'll be focusing on in this learning goal. So we want to match up problem number 1 to any one of those polynomial identities. So if you look at this problem, this actually matches up with this identity right here. Because you have you have two terms inside, a and b, and you have a parentheses, and then you have it squared. So this matches up with identity number 1. So we're going to be using number 1 here, a plus b squared. So then we're going to be looking at the right hand side here. So let's identify a and b here. So a is clearly going to be 3, and b is going to be -5x. We include the negative because the formula doesn't have a negative in it, so this is why we include the negative for the b. So now, plugging it into a squared plus 2ab plus b squared, we get 3 squared plus 2 times 3 for a, -5x for b, plus -5x for b squared. And we get 9. 2 times 3 is 6. 6 times -5 is -30, so -30x. And then 5 squared is 25, so I get 25x squared. So for number 2, this looks like, so if you compare the two expressions, it actually looks like this one, where you have something minus something, something plus something in parentheses. So that's our a minus b, a plus b. It doesn't really matter that these are in different orders, right? It doesn't really matter. You have both of them in there, so it matches up with that expression. Okay, so in this case, this matches up with a minus b times a plus b, which means that we're going to be using the a squared minus b squared here. So clearly, a is 2x cubed, right, this guy. And then clearly that b is going to be 3y. All right, so now if we use the left-hand side, a squared minus b squared, right? We're going to be plugging it into this one. Then we get, well, a squared, so a is 2x cubed, so we got to square that, minus b is 3y, and then we got to square that. So we get 2 squared is 4. X cubed to the second power is 6. You got to multiply those two exponents together. Minus, then we got 3 squared is 9. And then we got y squared. So we got 9y squared. All right, we got another problem here. So if you look at this one, number 3, you have a parentheses with 2 terms and then a parentheses with 3 terms, and then you got a minus sign there. So if you look at the polynomial identities, it matches up with this guy. You got a minus sign here, and then you got 3 terms here. So therefore, we're using the a cubed minus b cubed identity. All right, so I'm going to go ahead and write that so that we can see that it matches up. A minus b, a squared plus ab plus b squared. So in this case, you can kind of tell that a is x by looking at that, and b is 2. So a is x, b is 2. So now this is equal to a cubed minus b cubed, because that's that cubed identity right here. So now we know what a is, we can plug it in. So we get x, a is x, so to the third, minus b is 2 to the third. And so x cubed is just x cubed. 2 cubed is 8. So this is our guy. All right, so you just got to match it up and then plug in a and b. So now the next thing, we're going to be using the polynomial identities again, but learning goal number 4 is to be able to use them to factor expressions rather than multiplying. So same deal, we've got to identify a and b from the identities. So if you look at number 1, number 1 matches up closely with this one, a squared minus b squared. So it matches up with a squared minus b squared. And the reason why is that this is a perfect square and this is a perfect square. So I know that the square root of 64 is 8. I know that the square root of 25 is 5. So I know it works out nicely. So I can rewrite this as 8 squared minus 5y squared. That way when I distribute the square here, I get 25 there and I get y squared there. So now we can tell that a is 8 and b is 5y. So now that we know what a and b are, we can plug it into this right-hand side. So we want to plug it into a plus b times a minus b. So in that case, we get 8 plus 5y times 8 minus 5y. All right, so now looking at number 2. So number 2 has 3 terms in it. No parentheses or anything like that. So if you compare it, it looks like this, right? And if you notice, we can identify a from this based off of a squared and b squared. So let me write that out. We got a squared plus 2ab plus b squared. So for this, how do we identify a and b? Well, if you look closely, b squared has to be 16 and a squared has to be y squared, right? So a squared has to equal y squared. Well, if a squared is equal to y squared, that means that a is equal to y. And if b squared is equal to 16, well, what does b have to be? Well, you have to take the square root of both sides, right? So the square root of 16 is 4. So 4 squared is going to give you 16. So now we know a and b. So we can plug it into this left side, a plus b squared. So we have a plus b squared. So if we plug that in, we get y plus 4 squared. All right, so now for number 3. Number 3 matches up closely with, I see a cube there, and I know that that's a perfect cube, and I know that this is a perfect cube, and I see a plus. So it closely resembles number 4. So, what is the cube root of 64? A number that multiplies by itself 3 times to get to 64 would be 4, since 4 times 4 times 4 is going to be 64. And then I know that the cube root of 27 is going to be 3, because 3 times 3 times 3 is 27. So these are perfect cubes here. So this is a cubed plus b cubed. So I got to rewrite this. So I know that this is going to be 4 to the third, and then I got z. Now if I distribute the cubed here, I get 4 cubed to 64, z cubed to z cubed, and I get the original. Plus, and then cubed, this has to be 3, just like we mentioned here. So now we know that a is 4z and b is 3. So we're going to take the a and z and we're going to plug it in to this right hand side. So a plus b, a squared minus ab plus b squared. So if we do that, we get 4z, a is 4z plus b is 3. We got 4z squared minus 4z times 3 plus 3 squared. We just got to simplify a little bit. So we got to distribute a squared. 4 squared is 16. And then distribute the squared to the z, so that'd be z squared. 4 times 3 is 12, so it's minus 12z. And then 3 squared is 9. And that's our guy. All right, so learning goal number 5 and 6 are to use the remainder theorem and factor theorem. So use the remainder theorem to evaluate polynomials to get the remainder. And then learning goal number 6, use the factor theorem, remainder theorem, etc. to determine if a binomial is a factor. So we got this division problem here. Remember that this is our divisor, and then this is our dividend. So we look at our divisor, which is x minus 3, and we figure out what makes that equal to 0. Well, x is equal to 3 is going to make that equal to 0, right? So you're going to take that 3 and you're going to plug it in to the polynomial. So we'll call this dividend f of x. So that means it's going to be f of 3. We're going to plug in 3 into here. So we have 2 times 3 cubed minus 3 times 3 squared minus 10 times 3 plus 3. Just plug it into that dividend. And then you're going to do the math here. So we get 54. When you do this right here, you got to do two. You got to do the you got to do exponent first. So 3 to the third power is 27. And then 3 squared is 9. And then 10 times 3 is 30 plus 3. And then you got to do 2 times 27. 3 times 9. And then if you did this, 27 minus 30. So I get 0 here. So this means and this is our remainder. So we know that our remainder is equal to 0. Now, since our remainder is equal to 0, this means that x minus 3 is a factor. So remember, the remainder theorem says that if you plug in, the number from the divisor into the dividend, then that'll give you the remainder. And so if that remainder is 0, then that means that the divisor is a factor. If that remainder is not 0, that means the divisor is not a factor. All right, so number 2. Again, so looking at our divisor here, we got to figure out what makes that equal to 0. Well, that's easy. Just subtract 2 on both sides. So x is equal to -2. So then you're going to take that -2 and plug it into the function. So we'll say that, we'll call that f of x. So it's going to be f of -2. So we're going to bring it down. 10 times -2 cubed, x is -2, minus 11 times -2 squared, minus 47 times x is -2 again, plus 30. So we got 10 times -8. You got to do the exponent first. 11 times 2 squared is 4. And then this is going to be 47 times 2, so 94. So 10 times -8. 11 times 4. So you got -124. -30 plus 30, which is equal to 0. So our remainder is 0, which means that x plus 2 is a factor. Is a factor of, of f of x. All right, learning goal number 7. We want to be able to divide polynomials using long division. So this example is from the color by numbers activity that we did some of you picked up in class. So in order to do this, remember that to do long division, remember your divisor goes on the outside and your dividend goes on the inside. So the dividend goes on the inside, divisor on the outside. So we got our divisor is a plus 2. Now the dividend has to be put in standard form for you to be able to divide nicely. So we got to put this in standard form. That means the a cubed term goes first, so a cubed, and then the 13a squared goes second, and then the 13a term, and then the -11 term. All right, so then we got to fill in the blank. So a times what is going to give me a cubed? That's going to be a squared. So a squared times a is a cubed. A squared times 2 is 2a squared. So we got to subtract. So a cubes cancel. 13 minus 2 is 11, so we got 11a squared. Now we got to fill in the blank again. So what times a is 11a squared? And that'll be positive 11a. So 11a times a is 11a squared. 11a times 2 is 22a. Got to subtract. So it cancels out. I forgot to bring down the 13a here, so let me bring that down. So now you got to subtract these two together. 13 minus 22 is -9a. Bring down the -11. Now we have, How many times, so we got to fill in the blank, how many times, so a times what is negative 9a? And that'll be negative 9. So negative 9 times a is negative 9a. Negative 9 times 2 is negative 18. Subtract. Cancels. Negative 11 minus negative 18. These two negatives turn into positives. So negative 11 plus 18 is 7. So that means we have a remainder. All right, so we got our quotient and we got a remainder. So we got to put this in the two forms. So we're going to put this in the product form and the quotient form. So for the product form, we have our dividend is equal to our quotient times our divisor plus our remainder. So that's our product form. Our quotient form is dividend over divisor equals quotient plus remainder over divisor. All right, now this is another example. These are a couple examples from the maze activity. So I want to make sure that you guys know how to do that. Again, the key is on the class website, or will be. So, but I just want to go over some of those examples. So let's look at this one. I'll call this number 1. I'll call this number 2. All right, so we have for number 1, (2x squared minus 10x minus 26 divided by x minus 7. Okay, so our dividend goes inside, divisor on the outside, so we got to fill in the blank. So x times what is, or what times x is 2x squared? That'll be 2x. So 2x times x is 2x squared. 2x times negative 7 is negative 14x. Subtract. These two negatives become a positive, so we got negative 10 plus 14 is 4x. Bring down the negative 26. Now you gotta fill in the blank. So x times what is 4x? That would be positive 4. So we got 4 times x is 4x. 4 times negative 7 is negative 28. Subtract. These two negatives become positive, so negative 26 plus 28 is 2. So we got our remainder. Okay, so we're gonna put this in the in the maze. They want it in quotient form. So if you notice these two things, these are in quotient form. So we're gonna do this in quotient form. So to do this in quotient form, we have dividend over divisor equals quotient plus remainder over divisor. So this is the part that they want you to match up in the maze. 2x plus 4 plus 2 over x minus 7. So it looks like this one's correct. So you're going to be traveling that way in the maze. I also want to make sure all right, I also want to make sure that you know how to do number 2 over here, even though you you may not do that problem until later, but I want to show you how to do that. That one's a little bit longer, more involved because there's more terms. So let's do that over here. All right. So we got to figure out, fill in the blank. So x time, or what times x is x to the fourth? That would be x to the third. So we have x to the third times x is x to the fourth. X to the third times -1 is negative x to the third. Subtract. Cancels. These two negatives become a positive. So we got 7 plus 1x cubed is 8x cubed. Bring down the negative 6x squared. Fill in the blank. So blank times what times x is 8x cubed. That would be a positive 8x squared. So 8x squared times x is 8x cubed. 8x squared times -1 is negative 8x squared. Subtract. These cancel. Two negatives make a positive. Negative 6 plus 8 is 2x squared. Bring down the negative x. Fill in the blank here. So x times what will give you 2x squared? That would be positive 2x. So 2x times x is 2x squared. 2x times -1 is negative 2x. Subtract. These first two terms cancel. Double negative becomes a positive. There's an invisible 1 here, so -1 plus 2 is 1x. Bring down the -9. Fill in the blank again. So what times x is going to give you x? That will just be 1, positive 1. So now we have 1 times x is x. 1 times -1 is -1. Subtract. First two terms cancel. And these become the double negative, so it's a positive. So -9 plus 1 is 8. So that's our remainder. So then if we write our final answer in quotient form, we would say that our dividend over our divisor is equal to our quotient plus our remainder over divisor. X cubed plus 8x squared plus 2x plus 1. Oh, there's something wrong here. This should be a -8. I forgot to include that, sorry. So this is a -8. So I added those incorrectly. So that should be -8 for our remainder. So in that case, this is the answer to that question. So you would travel in that direction for the maze. All right, guys, that's it for the review. That was division, that was factor remainder theorem, that was standard form, degree, end behavior, and polynomial identities. I hope this video helped, and I will see you in the next one.